Alright, so you have already been introduced with this topic in class ninth, where you have all studied the three basic equations of motion and some problems related with the average speed and average velocity. And also in class ninth, you were told some basics related with scalars and vectors. Uh, the major topic which was related with the scalars and vectors was like the speed and the velocity, where you might have been told that speed could be speed is always positive, but velocity could be negative also. All right, so we'll keep these basics in mind. And you all remember that in class ninth I told you one topic which was the parameters of motion. So keeping all those things in mind, we have to go through this topic today, and let's continue with this now. So let's brush up some concepts. The first thing is the average speed and the average velocity. So in class ninth, I already told you that the average speed is the total distance covered. Let's take some intervals here. I have already introduced you this thing. So if there are four intervals here, 1, 2, 3 and 4. So the average speed is the total distance covered, whatever it could be, divided by the total time taken. And in the case of the average velocity, it is the total displacement covered. Now the displacement always depends upon the initial and the final position. Alright, now let's try to solve one problem and then we'll proceed further. Now check this, we have one third of the distance which is covered with this speed. So we can make three different intervals here. So this is one third and the total distance is 3x. So what we have is, if this distance is x, all the three distance will be x here. And this is 10 kilometers per hour. This is 20 kilometers per hour. And this is 60 kilometers per hour. Now what we need is, we need the total distance covered and the total time taken. So what we can do is, the time taken in the first region, in this one, we can find that t1 will be x divided by 10. In the second one, it would be t2 is equal to x divided by 20. In the third one, it would be x divided by 60. So these are the three time intervals. Now the total distance is 3x, that is x plus x plus x, and it has to be divided with the total time, that is x by 10, x by 20 and x by 60. So that is the average speed. Okay, and here what we have is, we have the case in one dimension only. The case is going in one direction only. So in this case, when the body is not even trying to come back to some position, or it's not regaining its position again, the position which it has already covered, what I mean to say is, like, it's not coming back here, like it is coming back to this point. So the case is like it is going from this point to this point, that's it. Now in this case, the average speed and the average velocity will be same. Alright, now you can solve this. This is a simple mathematical relation or simple mathematical fraction. You can easily solve this and you can get this answer, 18 km per hour. And in this case, the average velocity will be the same. Now, how to use vectors in this topic? In the previous discussion, in all the topics, whatever we have discussed earlier, I have already told you that the vectors is the most important part of physics, and without vectors we can't proceed. So how can we use vectors in this topic, in this kinematics? Like, first we'll try to discuss the average velocity. Alright, now see this thing. Let's imagine the situation. in this case we have a ship which is moving in the east direction. So let us suppose that it's going here with the speed of 12 kilometer per hour. So it is moving for 1 hour. So what will be the displacement covered? That is S1 vector, which is equal to 12 kilometer per hour multiplied by 1. And also you have to specify the direction. If it is east, we'll write I cap. Okay, so this is 12 kilometers the ship is covering in the east direction in 1 hour. Now, after some time, it turns exactly south with the speed of 5 kilometer per hour. Fine. So, as this is two-dimensional plane, I am not able to draw 3D in this 2D. So, what we can suppose is, we can suppose the direction. I can suppose S2 will be equal to 5 multiplied by 1 hour. So, this is 5 minus k cap. The south direction is minus k cap. Okay. So, these are the two displacements now. Now, average velocity, I have already told you, that is the total displacement divided by total time. So what we can do is, we can just simply add these two displacements here. Okay, we can add these two displacements here and divide with the total time. The total time is 2 hours. So what we'll get is, like, that will be 12 I cap minus 5 k cap divided by 2. Okay, so this is the average velocity. Now, most of the students will try to attempt this question with the magnitude, but I don't suggest you to go with the magnitude, because vectors is the precise form of physics. With the vectors, you can actually calculate the exact answer. Okay, so try to use vectors as much as you can use them. So this is the average velocity here. Maybe if you want to take a magnitude of this, you can take it in the end, but it's not required. It will never be asked to you. You always have to be more precise in the terms of two-dimensional motion. So you have to use vectors. Now I have some try yourself for you. You can try them at home and we can discuss the problems related with these two try yourself in the next session. Let me proceed further with the equations of motion. So these are the three equations of motion. V is equal to u plus at, s is equal to ut plus half at square, and v square minus u square is equal to 2as. So the derivations you might have done in class 9th, and we can just review them within one go. So the first thing is the acceleration, that is defined as change in speed or the change in velocity per unit time. So you know the symbols. If it is moving from this point to this point, like if it is if it is u to v in the given time t, so that is always final minus initial divided by time. Now the next thing is, you can rearrange this relation and you can get v is equal to u plus at. So that's as simple as possible. Now the second equation of motion is the average velocity multiplied by time, that is the distance covered. This thing is from the same formula which we discussed right now in the average velocity. The average velocity or the average speed, that is equal to total displacement divided by total time taken. So you can multiply this time here and you can get the total displacement of the motion here, whatever it is. Now the total distance covered will be s, and in the case of accelerated motion, I am telling you this thing, just remember this fact. In the case of the accelerated motion, you can take average speed as v plus u by 2. We'll go into the mathematical reasoning of this thing later on, but for the while you can just remember this thing. So let's substitute the values. This is v plus u by 2 multiplied by t. We have to do one thing, we have to substitute this value of v here. So this will become u plus at plus u. And you can again simplify this term and split the LCM here. If you split the LCM here, you would get the second equation of motion. Now to get the third equation of motion, what we can do is we can calculate the time from here, which is v minus u by a. And if you want to go with the easy method, so this will be v plus u multiplied by v minus u divided by a, and you can directly solve this. 2 will go here, a will go here on this side, on this side. So this will be like 2as is equal to v square minus u square. So this is like derivation of the third equation of motion in one step. But otherwise what you can do is you can substitute the values here and you need to solve this whole. So I suggest you to practice it once if you want, otherwise it's fine. In the class 11th we have to be active on more of the use of these equations. So you can try it once. And now let us come to the first main important topic of this kinematics. That is the distance covered in the nth second. Okay. Now in this case, we'll try to use the second equation of motion, which is like s is equal to ut plus half at square. So we know this thing that the total distance covered, like it starts from 0 to total time n seconds, the total distance covered will be ut plus half at square. We can substitute the time as n here. We can substitute the value of t as n. Now the situation is, I can just take 1 second before this. Now what exactly is this whole situation? I must tell you one thing. There is a difference between nth second and the total time. Like I'll tell you this thing. This is 0, 1, 2, 3, 4, 5 and 6. This is time. T is equal to 0, 1, 2, 3, 4, 5, 6. Okay. So these are the intervals here. Now maybe I could be asked by a question that I want to calculate the distance only in the fourth second. So what exactly is the first second? I should tell you, this is first second. This duration is the first second of motion. This is second of motion. This is third, this is fourth, this is fifth, and this is sixth second. Now if I need, there is a difference in the statement. Now try to understand this. Distance in 6, or you can take 5 seconds. So what you will do, you will calculate the whole distance from this point to this point. Okay, so this is the total distance covered in 5 seconds, like the distance in 5 seconds. If I want the distance in fifth second, now what does this statement means? This statement means that I need to calculate only this much distance. Only the distance covered in this duration, this one. So this is the distance traveled in the particular second. Okay, the particular second here I am denoting it with the nth second. Nth second means like it could be the any nth value. Fifth second, like the fifth second here. Okay. Now, how to calculate this? That is the major thing here. So, what we have is, we have the total distance covered in n second, which is s is equal to un plus half an square. And after that we have the distance covered in n minus 1 seconds, like just 1 second before that. Okay, so we can substitute the value of time as n minus 1. Now what we have is, one distance we have the whole from this point to this point, and the second we have from this point to this point. So if we subtract these two distances, if we are just going to subtract these two distances, we'll only get this distance Sn, the nth, the distance covered in the nth second. So this requires a simple mathematical solving, a simple algebraic expressions, like you have to open up the brackets and you have to solve this whole stuff, and you will definitely get the answer. Maybe I can help you a little, but you have to be quick in the calculations. This will be un minus u, and this is n square minus 2n plus 1, and then you have to multiply half a with all these three terms. So you would get this half an square, minus will become positive because of this negative here. So this is an, and minus a by 2 will be because this is only 1 here. You can solve this easily, just opening up this square and opening up this bracket, and then just removing this bracket and multiplying the negative sign throughout with the terms. So you will definitely get this result. Now you can cancel out this un and un. An square gets cancelled out. You are only left with u, an and a by 2. So these are the three terms which are left in the relation here in this equation. And what we can do is we can take a as common, and it would be just n minus half. So this formula is correct. This will work out, but in the books it's written like in this form. You can multiply the 2 here and take this 2 out here. So this is the distance covered in the nth second, this one. Now this is the distance covered in the total time. This is in the nth second. So there is a difference which you have to understand. The distance covered in the particular second and the distance covered in the total time. Okay, so this is important derivation. It might come in your school exams also. Now let's try to practice one problem which will be related with this. So keeping the same thing in mind which I have already told you, let's go with this question. So here in this situation, we have been given a body covers 12 meter in the second. Alright. So you always have to draw the intervals. So this is 0, 1, 2. So it has been mentioned 3, 4. So the case till here it's given. Alright. Now it has been mentioned here that the distance covered in the second is 12 meters. So this distance covered is 12 meter. So this is the particular second. Okay, so for the particular second, we use this relation. Fine. And then after that, let's try to substitute the values here. So in the first case, this will be the first equation will be u plus a by 2. We have not been mentioned with the initial speed and the acceleration. These two variables are not mentioned in the question, u and a. See, I must tell you one thing. The problems which will be related with the motion or the kinematics related with this topic, in most of the numericals, I think u and a will not be mentioned to you. You have to calculate it by the simultaneous equations. Like it was like a topic of linear equations in two variables. You have already done those equations in class 10th. Okay, so this will be u plus a by 2, and with the bracket of 2 multiplied by 2 minus 1. Fine, so this is the first equation. Like the distance covered is 12. So you can solve this equation here. And the second situation is given like 20 meter in the fourth second. So this distance is given as 20. So we can make the second equation also. 20 is equal to u plus a by 2 multiplied by 2 multiplied by 4 minus 1. Okay. So these are the two equations which we have in this situation. Now you can simplify these equations if you want. And when you simplify these two equations, this equation will be like 12 is equal to u plus a by 2 multiplied by 3, I think 3a by 2. And in the second case, it will be 20 is equal to u plus 7a by 2. Okay, and you can do one thing, you can subtract these two equations. You would get minus 8 is equal to, this would get cancelled up, and this will be 3a by 2 minus 7a by 2. I might have I might have done like the second equation minus the first equation here. This is equation 2 and this is equation 1. Okay, but it's either way it's fine because the answer will be same. So this will be minus 4a by 2 will be equal to minus 8, and a should come out to 4. And when you substitute this a in any one relation, what we can do is try to get substitute in the equation where you have the numbers which are less. So the calculation has to be avoided. The larger calculation, large calculation, or the number of calculations have to be avoided. It should be very less. So this will be 3, 4, 12 divided by 2 is 6. And if you solve this, you will get u is equal to 6. So we have found u and a, which we need further in the equations now. Now that was only the analysis of this first line of the question. The second line I haven't touched, so let's try to figure it out. Now the situation is, this was the data mentioned till 4th second. Okay, we have to find the distance in 4 seconds after the 5th second. Fine. So this is 0, 1, 2, 3, 4, 5. So we need 4 seconds after this. That means 1, 2, 3 and 4. That means 6, 7, 8, 9. Okay. So we need this distance. Okay. We need this distance. So how will we find this distance now? Let me tell you one thing. The total distance which was covered here, that will be 9 seconds. This is the total distance covered. We can imagine it like this. Okay, and we can also calculate the distance in 5 seconds. So we can do one thing, we can calculate the distance in 9 seconds. That will be u multiplied by 9 using the second equation of motion. Now this is a large duration of time. This was the particular duration of the time. Okay, so this is the large duration, so this will be plus half a multiplied by 9 square. And for this one, it will be like the distance covered is equal to u multiplied by 5 plus half a multiplied by 5 square. So when you will subtract these two distances, you can take the symbols different, or maybe you can't take, you don't need this. So when you subtract these two equations, you will definitely get your answer. Or otherwise I should tell you one more formula which will be helpful to you in the case of durations here. Like if this is the situation, this is time 0, you can suppose this 0, this is t1 and this is t2. So if you want to find the distance between t1 and t2, if the initial speed is given here at time 0, okay, this is important, initial speed is always at time 0, so you have to suppose it here. Now if you have to find the distance between t1 and t2 in the motion, so this will be s is equal to u multiplied by t2 minus t1 plus half a t2 square minus t1 square. So let's substitute the values here directly, we'll get the answer. 6 multiplied by 9 minus 5 plus half a was 4. Half multiplied by 4 multiplied by 9 square minus 5 square. So this will be 4 multiplied by 6, that is 24, plus 2 multiplied by 81 minus 25. Okay, so it could be 56. So if you just add this, 2 multiplied by 56 is 112 plus 24. So this should be 136 meters. Okay, so this is the method. This is the way you have to proceed. I hope it's fine. Now let me proceed further. Okay, now these basic equations of motion can also be used in the graphical form. And in this lecture, I'll introduce you with the graphical form of the question. Let's try to understand this first. So this is an automobile which is starting and accelerating for 30 seconds. Then it's moving with the uniform speed, like the uniform velocity, and finally brought to rest. So if you make the graph for this question, it will actually become very easy. Okay. Now for the first 30 seconds, like for this interval, in this 30 seconds, it is accelerating. So you have all the data. U is 0, V is 20, time is 30. Okay, the time is 30. Now you can calculate the acceleration, that will be V minus U divided by T. So this should be 2 by 3 in the first case. Fine. Now the next thing is, in this duration, the distance covered will be the area of this triangle. So that will be half multiplied by 30 and 20. The area of the triangle is half base multiplied with height, and this will be 300 meter. Now the total distance was given as 950. So that means the total area of the graph was 950 because it is the velocity time graph. The area of the velocity time graph gives you uh, the distance, and these things I have already discussed in the previous session. So this will be like 950 minus 300 and minus 50. So you will get this particular distance, the distance in the second region. So this is the first region, you can mention this as second region. So this will be 600 meter. Okay, and it is moving with a constant speed. So what will be the time? The time will be 600 divided by 20. So this is 30 seconds. Fine. Okay, now let's go in the region 3. Here we have u is equal to 20 and v is equal to 0. Okay, the initial speed is 20 and the final speed is 0 because it's trying to stop here with some constant retardation. Let's try to find now. And the distance is 50 here. So we'll use the third equation of motion, v square minus u square is equal to 2as, and we'll get the answer of acceleration as negative here because it is retarding. So this is 0 square minus 20 square divided by 2 multiplied by 50. So if you solve this result, it should be minus 4. The acceleration has to be minus 4 here. And what else we need? We need the time in this region. Fine, we can use the first equation of motion. V is equal to u plus at. V is 0, u is 20 minus 4t. So what is the time? Time will be 5 seconds. Now if you add the time 30 plus 30 in the region 2, because this was the 30 second which I took, that was the first region, then it was the second region, and plus 5 the last region, third region. So the total time is 65 seconds. So I think we have got all the things which are required, which are asked in the question. Acceleration is 2 by 3, retardation is minus 4, and the total time taken is 65. Yeah, so just check it out now. Okay, now let me proceed further. The motion is actually a very vast topic, but only with these three equations you can imagine that the large range of the topics we can cover with only these three equations. And now let us take one example which is related with the gravity. So there is a situation, and I should tell you one thing. This question is very important because um, there will be lots of questions which I can make from this one in the upcoming topics in the laws of motion, in the work power energy also, and in the collisions. So there is a situation, a tennis ball is dropped from a height of 4 meter and it is rebounding to the height of 3 meters. Okay, so I should tell you one logic. Now there is a logic of drop, like dropping a ball or the free fall. There is a logic for this. If you drop this ball, the speed at the bottom, that is 2gh. Okay, if this is height h, the speed is 2gh. This is one thing. Okay, and let us suppose if you have to send this ball to some height here, like this height is h, so the speed, like if the ball has to reach till this height, the speed at the ground should be 2gh. This is the second thing. Okay, this is the first case, this could be the second case. You have to remember this fact. This can easily be derived with the third equation of motion, like v square minus u square is equal to 2gh. So I'm just telling you, if the ball is dropped from the top, the speed at the bottom has to be under root 2gh. And if the ball is projected from the bottommost point and it has to reach a height h till the top, so to reach that height h, the speed should be under root 2gh. And this is the ideal case. I'm not taking in account any friction. The air friction I'm not taking into account. Fine. So the speed at the ground, just remember this thing, whether it is going up or it is reaching the ground, in both the cases the speed is 2gh, under root 2gh. Now let's come to this question, let's come to this discussion. This is very important now. Now the thing is, if it is being dropped from the height 4 meters, so the speed on reaching the ground is 2gh1, and if it has to reach a height of 3 meters, then the speed will be 2gh2, because the heights are different, given different here. And how we define acceleration? This is v vector minus u vector divided by t. Very simply I am telling you this thing now. So the thing is, this is the initial case and this is the final case. Okay, in the initial case I can make the u vector is equal to this whole thing and with a direction negative j cap, because it is coming downwards. And in the other case, if I am taking this v vector, this is equal to under root of 2gh2 j cap, because it is going upwards. Okay, so now, and if you want, you can take the gravity as 10 if you simply want to solve this whole question. So this will be equal to under root of, so if I solve this, this will be 3 multiplied by 2, this is 6 into 10, so this is 60 under root 60 j cap, and u will be equal to under root 80 minus j cap. Let's substitute the values here. This is 60 j cap minus of minus 80, no, under root 80. You don't have to take the negative sign inside the under root. otherwise you will enter the mathematics of complex numbers. So this has to be divided with 0.01. Now you can easily solve this. This will become under root 60 plus under root 80 divided by 0.01, and a direction is j cap. So you can solve this with the calculator and you will definitely get the answer. So this is one way, this is one approach for this question. Now the second thing is you can take in parts, like when the ball is coming downwards, obviously you can use the third equation of motion and you can calculate the speed v1, that is under root 80 only. Okay, because u will be 0 and there will be one speed v1 at this point, like at this point when the tennis ball will be coming like this. After that it might deform its shape, and then again when it has to go back it can regain its shape and go back. But obviously in this deformation there will be some energy loss on the ground. Okay, and similarly I'm using the third equation again because the ball has to stop at the top point at height 3 meters now. So this was under root 60 which I calculated there. So again you can do the same thing, like it is change in speed divided by the time. So you will get this large amount of acceleration here. Alright, I hope it's fine. The first method is comparatively easier than this one, that is direct approach, and that is better. Now let us proceed further. Okay, so this motion will now be discussed here as a relative motion in this question. So that's like if there are two particles which are moving from point A to point C and from B to point C. So the basic thing is, in the case of relative motion, there is one important thing which I should tell you, that is like um, the time has to be same. Okay, the time has to be same. Alright, let's discuss this problem first. Now the radius is given as 5 meter. This is 5 meter and this will be 3 meters here because this is 2. Now the next thing is, if this is 5, this is 3, this BC has to be 4 because that will be 5 square minus 3 square, and this AC, if this is 4, this is 2, so AC has to be 4 square plus 2 square, so this will be 16 plus 4 under root 20. Okay, so these are the two distances here which will require. Now if the particles are moving along this AB and BC, we need the ratio of speeds. So you can calculate the ratio of speed because it has not been mentioned anything like to reach here, but we can imagine that if they reach here at the same time, then the time taken will be equal, but it hardly matters, you know. You just have to find the ratio of the speeds. You can directly find the ratio of the speeds also. So that will be just distance covered by time taken. Okay, because speed is directly proportional to distance. So what you can do is you can directly equate u1 ratio u2 is directly equal to d1 ratio d2. Simple. So you will get the answer from here itself just by equating these two. So this is a relative motion, like the question which was given here. This is related to the relative motion. Alright, now just by discussing these basics here related with the motion, let's get over to some problems, the unsolved problems here. Now this is related with the basic three equations of motion but the same thing which I told you earlier, u and a will not be mentioned. You have to solve it yourself. Okay, so let's try to discuss this. So there is like a body in motion. As it crosses a fixed point, let us suppose this is the fixed point, the stopwatch has started. So this is time 0, and it travels a distance of 180 meter in the first 3 seconds and a distance of 220 meter in the next 5 seconds. So this will be 8 seconds here with the motion 3 plus 5. Okay, so now the approach says u has to be taken here itself. You can't change the point. You can't change the point again and again. Okay, and after this there will be two situations. One is the situation till 3 seconds and the second situation is till the 8 seconds. Alright, let's go get over with these equations now. So one is the second equation of motion we'll be using here. S is equal to ut plus half at square, and we don't know what is u and what is a. So this will be equal to 3u plus half at square. T square is 3, so this is 9 by 2a. That's the first equation. Let's try to simplify this. Divide this whole equation with 3. So you will get 60 is equal to u plus 3a by 2. And in the second equation, you have to start it from the starting point only. This will be 400, 180 plus 220. 400 will be equal to 8u plus a by 2 multiplied by 64. Simplify this equation also. Divide this whole equation with 8. You will get 50 is equal to u plus 8a by 2. That is 4a. Okay. So now what we have is, we have these two equations which will help us to find u and a. Let's subtract them. So we get 10 is equal to 3a by 2 minus 4a. Fine. So this will be 3 minus 8a divided by 2, and this is 10. So a should be equal to 4, negative 4, and you can substitute it in this equation, or maybe this one. I think this is better. So 4 multiplied by 4 is 16, and if you subtract it, oh no, this will be getting added up here, because this will be 50 is equal to u plus a. A is negative 4 and this is 4, so this will be 50 plus 16 here. This is u. This will come out to be 66 meter per second. Okay, so now we have u and now we have a. Now let's get to the question. So what is the velocity at the end of the 9 second? Fine. So what we can do is, v is equal to u plus at. So this is like 66 plus a, which is negative 4, multiplied by 9. So this is 66 minus 36. So this should be 30 meter per second. This is the answer what we have. I hope it's clear. Alright, now let us get to the second question here. So this is related with the same example which we have already done, but we can practice this once. So this is like 4 meters in the third seconds. So definitely we have to use the equation of Sn here, which is u plus a by 2 multiplied by 2n minus 1. So let's substitute the values directly. 4 is equal to u plus a by 2 multiplied by 2 into 3, that is 6 minus 1 is 5. And the second equation is 12 is equal to u plus a by 2 multiplied by 2 into 5 minus 1, that's 9. You can simply substitute the values and solve this. Subtract these two equations. So this will be negative 8 is equal to 0 minus 9a by 2 plus 5a by 2. So this will be minus 4a by 2, and negative negative could be cancelled up. So a is again 4 here. I think in that question also it was 4. And let's substitute it in this relation. This looks comparatively easy. So if you substitute here, this will be 4 is equal to u plus 20 by 2. That is 4 multiplied by 5, 20 divided by 2. So this will be, u will be negative 6 here. Okay, so we have a and we have u. Now we need the distance covered in the next 3 seconds. Okay, so now we have to make the point diagram. Always whenever you are approaching the problems related with the kinematics, try to draw this point diagram. This is very important. This is 1, 2, 3, 4, 5, 6, 7, 8, 9. I think we need 0 also. Okay, so this is the situation. So it was till 5th second here. This was given till here, and we need the distance from 5th to 8th because it is like going in the next 3 seconds. Fine. So I've already told you the distance covered is u multiplied by t2 minus t1 plus half a multiplied by t2 square minus t1 square. Substitute this here and you will definitely get the answer. This is negative 6 multiplied by 8 minus 5 plus half a, that is 4 multiplied by 8 square minus 5 square. Alright, let's get with this now. The final steps of the calculations are like 8 minus 5 is 3, 18. This will become negative 18 plus, this is 2 multiplied by 64 minus